All right. Good morning. Happy Thursday. Okay, so you turned in the angles and angle measurements. That was on last night. And tomorrow are the arc and arc length. Take it back. You turned in both of those on Wednesday, and on Friday is lesson 17.1 from the book. All right. Anybody want to ask me any questions about any of that stuff? Okay. Well, yesterday I started teaching lesson 17.2. So a lot of you are letting me know about the AP testing, but a lot of you aren't. And so I don't know who's taking tests and who aren't. So make sure that if you're taking AP tests that you watch the video that I posted on YouTube of the lesson from yesterday. Otherwise, you're going to feel completely lost. And the other thing is I'm not teaching like the book. So don't ask me about the book. I don't know what they're doing. They're teaching this stuff really, really difficult, in my opinion, and I'm not teaching like the book. So if you're looking at the book, good luck with that. If you understand it, fine. If you don't ask me about it. You want to look at your notes that I'm giving you. Okay? Okay. So the main thing that what I talked about yesterday is I was talking about the unit circle. And we basically are just talking about common angles right now, okay? So what I started doing yesterday is I was showing you how to use the reference angle and the quadrant to evaluate a trig function. And so what I want to do is I want to do a bunch more problems today. And if you noticed, I posted something that says unit circle quiz. That is not a quiz. Okay, what that is, it's going to be some practice problems. Okay, so I'm kind of leading you into this, and it's going to be practice problems, and that is going to be due on Tuesday. So I'm hoping that I can get through a lot of that today and clear up a lot of confusion. The other thing I taught yesterday is I showed you how to use your hand to come up with, remember that the angles are measured in degrees and radians. Okay, so yesterday I showed you some common angles in degrees and radians. In addition to that, there's points on the unit circle that are associated to those angles. So those points are ordered pairs. And I showed you how to use your hand to come up with the ordered pairs. So you have to use your left hand and you have to put it out like you're looking at a ring, like you're looking at something on your hand. So for example, well, we discussed this, that all the denominators have a 2. All right. And all of the numerators are radicals. So if you hold your hand up, your thumb and your little finger are the X and Y axis. So if you put your first finger down, it represents that angle. Let me draw the circle here. So if you put your first finger down and I ask you, what is that point? You would tell me it's radical 3/2 and 1/2. Now that's the point on the circle. The angles would be 30 degrees and pi/6. Okay. If you put your middle finger down, you get radical 2/2 and radical 2/2. That represents that point on the circle. And if you put your fourth finger down, you would get 1/2 and radical 3/2. So what I was saying yesterday is that you need to make sure you know this, because we're going to use this to come up with other points and other angles. And it's very important that you know these. So that quiz that I posted is asking you to write down all this information. I want you to write it down without looking at your notes. So I don't want you to do that assignment or even look at it until you memorize these things and know how to do your hand. I don't want you looking at your notes. I want to know, do you know this? It's not a quiz. I made an assignment, but I don't want you looking at your notes. All right, now does anybody have any question about the angles or the points that are associated to these angles?
Miss Birch, so when you use your hand, like say you put down your first finger and you get 3 and 1, those are just the numerators, right? It's not the
Right, it's
denominators?
the denominators are always 2. So we just forget about the denominators because the denominators are always 2. And the tops are always radicals because radical 1 is 1, right? So we could say that all the tops are radicals.
Oh,
so
okay, that makes more
when
sense.
I put my first finger down, that's going to be radical 3/2 and radical 1, or 1/2. When I put my fourth finger down, it's going to be radical 1/2 and radical 3/2. So
Okay,
right,
that makes more sense.
Your hand is only showing the numerator, right?
Okay,
All right.
thank you.
Is anybody else still confused about your hand? All right, so yesterday I worked one problem and I just want to work a few more problems and take some questions, okay? All right, so here's the next problem. Seven pi over 6 radians. So remember, if I don't write radians, radians is implied. All right, so the first thing we're going to do is we're going to find the reference angle. Now, the thing about the radians is we can cheat. Now, when I start doing degrees, it's going to be more difficult. But with remember the reference angle is theta prime? We can just cheat and say that the reference angle is pi over 6, because that's a positive acute angle in the first quadrant. I'm cheating and looking at the denominator. It's going to be harder when we work with degrees. I'm going to show you a trick about that too. All right. So the second thing we do is we evaluate the reference angle. So we're going to find the sine of pi over 6. Now, don't forget, and I'm just going to tell you, I'm going to give you some tips here. Your ordered pair is cosine of theta and sine of theta. So what this is saying is that cosine of the angle is the x value, and sine of the angle is the y value. Now, you're going to have to also know what tangent is. But it just so happens that tangent is going to be, and there's different ways it's defined. It's defined as sine of theta over cosine of theta, which we'll learn in pre-calc. It's also defined when we're talking about triangles as y over x. So in a little while, you better write this down. In a little while, when I ask you to find tangent, you're going to have to put y over x. So in this case, well, we'll get into it. All right, so cosine is x, Sine of theta is y, and tangent of theta is y over x. It's also defined like, well, it's also defined like that, so we'll just use that for now. All right, so back to this. So this is asking for the y value of the point when you have an angle of pi over 6. So look at your hand. Isn't pi over 6 this? Yes or no? It's pi over 6, yeah. Pi over 4, pi over 3, right? Right? Pi over 6, pi over 4, pi over 3, correct? So with pi over 6, what is the y value? The x value is radical 3 over 2. What is the y value?
1/2.
X value is radical 3 over 2. The y value is 1/2. Now, that's actually the answer for our actual angle. So our actual angle is sine of 7 pi over 6, and the answer is 1/2, but we have to figure out what quadrant our actual angle is. This is in quadrant 1. Remember the reference angle, positive acute angle in the first quadrant? Well, we need to figure out what quadrant 7 pi over 6 is in. And I showed you a way to do this yesterday. And it's going to be the same for degrees. You're going to go to the closest horizontal. Now, the book does not explain it this way, but I promise you this is the easiest way to do it. So yesterday I was talking about pi being on the horizontal 6 pi over 6, right? Well, if your angle is going in this direction, where is 7 pi over 6? I mean, you can draw the sectors if you want, but where's 7 pi over 6?
In the third quadrant?
Right. Okay, now, I was saying yesterday, we don't want to have to graph it all the time. Do you realize how long it's going to take us to do the problems? So what are the signs in the third quadrant?
They're negative, so you would just apply the negatives to the ones from the first quadrant.
We found the sine of pi over 6, which is we're evaluating the trig function in the first quadrant. So we know the actual angle. When we evaluate the actual angle, it's the same answer. We just have to incorporate the sine. And remember, sine is y. So that would be negative. And the reason why is because the actual angle is in quadrant 3, where the signs are negative, negative. All right, any question? We'll do another one. Ready? We'll do another one. And I'm only working in radians right now because it's the easiest. So we'll look at degrees also. Okay, can I erase this?
Yeah.
Now, you are not to use a calculator with the common angles. So we will be using a calculator for something like 5 pi over 12 or sine of 5 pi over 12, but you are not to use a calculator for this. Okay, these have to be done by hand. All right, so let's look at another problem. This is actually tangent of pi over 4. All right, so the first step is find the reference angle. Well, this is the reference angle because it's a positive acute angle in the first quadrant. So the second step is we want to, well, it's actually, we're just going to evaluate tangent of pi over 4. Well, isn't pi over 4 this? So isn't your ordered pair radical 2 over 2 and radical 2 over 2? Yes or no?
Yes.
And isn't this x and isn't that y? And didn't we just get through saying that tangent is y divided by x? Well, isn't anything over itself 1? Seven over 7, 8 over 8, radical 2 over 2 over radical 2 over 2. Isn't that 1?
Yeah.
So our reference angle was our actual angle. So there was no more work to do on this. So let's do this problem again, where the angle's not in the first quadrant. I'm going to erase this, okay? All right, now let's say that the problem was this. 11 pi over 4. So the first thing we want to do is we want to find the reference angle, which is just pi over 4. Well, how did I know that? Because working in radians easy. That's the positive acute angle in the first quadrant. So now we're going to take the tangent of pi over 4, which we already know is radical 2 over 2 over radical 2 over 2, which is 1, right? So
Yes.
now we want to look at the actual angle, which is tangent of 11 pi over 4, and we know the answer is 1, but we have to figure out what quadrant the actual angle's in. So look what I'm going to do. I'm not going to draw the angle. I'm going to go to the closest horizontal and go, okay, I know that's 4 pi over 4. So what would a full revolution be?
8 over 4.
Because 8 pi over 4 is 2 pi, right?
Yes.
And we already know that on the right side on the horizontal are the even pies, 2, 4, 6, and 8. Over here are the odd pies, 1 pi, 3 pi, 5 pi. So we're getting close. What would a half a revolution be?
10 pi over
12
4.
pi over 4.
12 pi over 4, which is 3 pi. Remember, you have this broken up into 4 parts, right? 4, 5, 6, 7, 8, 9, 10, 11, 12. Are you with me or no? If you have to draw
Yeah.
this, draw it for now. So this would be, remember, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi over 4, 12 pi over 4. I'm sorry. 9, 10, 11, 12 pi over 4, right? So we're looking for 11 pi over 4. So where is it?
In the second quadrant.
In the second quadrant. It's 1 back, right? So what are the signs in the second quadrant?
The signs are negative, positive.
That's correct. Now pay attention. Tangent is positive divided by a negative because tangent is y over x, right? Or sine over cosine, correct? So what's a positive divided by a negative?
Negative.
If you guys have a question, stop me. So the 3 things you're doing, you're finding a reference angle, which is a positive acute angle in the first quadrant. You're evaluating, evaluate means find a number, right? You're evaluating the reference angle, and then you're evaluating the actual angle by determining the quadrant of the terminal side. I'm not going to do anything with this. This is quadrantal. So I'm not going to find a reference angle. I'm not going to go through a bunch of work. I'm just going to use common sense. So where is 4 pi? Well, this is 0 pi, right? 0, what's over here? Pi. What's over there? What's a full revolution? 2 pi. What's a revolution and a half?
3 pi.
And revolutions?
4 pi.
Well, what is that point right there? If you're in a unit circle, unit means 1. What's that point?
One zero.
Right? 1, 0. What's this point?
Zero comma 1.
0 up 1. What's this point down here?
Negative 0, negative 1.
0 down 1. And what's that point?
Negative 1, 0.
And I'm warning you, you screw this up now and you're going to be missing all kinds of problems. So you mess this up now, you're going to be missing everything. So don't mess it up. That's why when I taught this, I told you to say right 1, 0, 0 up 1, left 1, 0, and 0 down 1. You mess it up now and you're going to be messing all kinds of stuff up. All right, so what is the cosine? That's the x value, right? What is the cosine of 4 pi?
1.
So we haven't even talked about negative angles, so let's talk about some negative angles. What is the reference angle for negative pi over 6?
Pi over 6.
Pi over 6. So those of you who are more visual, I'm going to show you what's going on here. Negative pi over 6 is there. So what would be the reference angle? Positive pi over 6. So this angle right here is negative pi over 6. And that angle is positive pi over 6. So we want to know the sine of pi over 6. Well, what's the sine of pi over 6?
One half.
1/2. So now, when we find the sine of negative pi over 6, the answer is 1/2, but we have to put ourselves in the right quadrant. Well, what quadrant are we in for the actual angle?
Quadrant 4.
Quadrant 4. Well, what are the signs in quadrant 4?
Positive, negative.
Positive, negative. So is sine of theta, is that x or y?
Y.
So what's this answer?
Would it become a positive 1/2?
You told me sine is y. I thought an ordered pair was x, y.
It'd be negative 1/2.
Negative 1.
So you understand what everybody's going to do, right? I'm going to have over 50% of my students mess up on positive and negatives. And guess what? There's zero tolerance with this now. So now you can't mess up on positive and negatives, because you mess up on positive and negatives, that means you don't know what quadrant you're in. So I'm going to say that again. Over 50% of my students are going to mess up on positive and negatives. So people are going to write 1/2, and I'm going to mark the whole problem wrong, 0 credit. You have to get the signs right. That's the whole principle of what we're doing. So you have to know what quadrant you're in. You can no longer mess up on positive and negatives. Now, I'm going to show you a way you're never going to get confused about this. C comes before S in the alphabet, just like X comes before Y in the alphabet. So don't ever screw up cosine being X and sine being Y. C comes before S in the alphabet, just like X comes before Y in the alphabet. Let's do some more. What am I on, F?
Yeah, you're on F.
Tangent of 9 pi over 4. What's the first thing you do?
Find the reference angle. Theta.
And what is a reference angle?
It's what's in the first quadrant.
Right. So which angle are you looking for in the first quadrant?
Pi over 4.
With radians, you just look at the denominator. All right, the second thing we do is we evaluate the reference angle. So you can hold up your hand, and we know that tangent is y over x. So what is y over x? All right, what's the ordered pair? What's the ordered pair that's associated with pi over 4?
It'd be radical 2 divided by 2 and radical 2 divided by 2. And then you would just get 1 because you divide them.
Right, but I'm going to show it. It's y over x, which is 1. All right, so in number 3, we're going to evaluate the actual angle, which is tangent of 9 pi over 4. Well, the answer is 1. We just need to figure out if it's positive or negative. So the question is, where is 9 pi over 4? Well, we know this horizontal is 4 pi over 4, right? Right? If you went around 4 pi over 4. So what's on the other horizontal? If you did a full revolution.
8 pi over 4.
Well, do you know where 9 pi over 4 is? Isn't it this angle right there? Yes or no?
Yes.
All right, so that's the first quadrant. What are the signs in the first quadrant? Positive, positive. So remember what you're doing here. It's tangent, which means positive divided by a positive. Right? Positive divided by a positive is a positive. So this is in quadrant 1. where the signs are positive, positive. Okay, now I'm going to make some notes and then we'll work some more problems. So notice that we're evaluating. Evaluate means find a number. So the values, when you evaluate, the values of the trig functions of a given angle theta are the same values of the trig functions of the reference angle theta prime. Right? Continue on here. A function value of the reference angle is always positive. Of course it is, because a reference angle is a positive acute angle in the first quadrant. So you're never going to have a reference angle anywhere but in the first quadrant. So a reference angle is always positive, the function value. However, the same function value for theta, in other words, the same function value for the actual angle may be positive or negative. And what's the reason for that? Because we have to look at the quadrant where the actual angle exists. So let's read this again. It says a function value of the reference angle is always positive. Of course it is. However, the same function value for the actual angle could be positive or negative. And let's add this, depending on the quadrant. And that's the quadrant of the actual angle. All right, now, I didn't really do any hard problems. Can I erase this?
Yeah, you can erase it.
Now, we're doing 3 basic trig functions: sine, cosine, and tangent. There's 3 more: cosecant, secant, and cotangent. So we're not going to do those. I'm just letting you know that those that I just mentioned, those are reciprocals. In addition to that, we haven't done, all I focused on was pi over 4. We didn't do tangent for the 30 degree, I mean, for haven't done tangent for pi over 3 or pi over 6. So let's do one of those. first thing we do is we find the reference angle. Well, this is easy. It's pi over 3. The second thing we do is we find the tangent of the reference angle. Well, what's the ordered pair? What's the ordered pair for pi over 3? Go ahead, hold your hand up. If you don't have it memorized, hold your hand up and look at it. What's the reference angle for pi over 3? I mean, what's the ordered pair?
It's 1/2 and radical 3 over 2.
Right. So tangent would be y over x, wouldn't it? And I'm just letting you know that when you have a complex fraction with the same denominators like that, the answer is going to be radical 3. So I'll prove it to you. So radical 3 over 2 divided by 1/2 is going to be radical 3 over 2 times the reciprocal, cross cancel, and you get radical 3. So whenever you have the same denominators like that, they just cancel out to radical 3. If you want to do the division, go ahead. All right, so now we're going to evaluate the actual angle, which is tangent of 7 pi over 3. So we know the answer is radical 3. But we have to know what quadrant we're in. So once again, we know that this is 3 pi over 3, a half revolution. A full revolution would be what?
6 pi over 3?
6 pi over 3. And then another half revolution would be what? 6, 7, 8, 9 pi over 3?
Yes.
So where do you think 7 pi over 3 is? Do you think it's in the second quadrant or the first quadrant?
The first
The
quadrant.
first.
Right. So the signs in the first quadrant are positive, positive. So remember that tangent is y over x. So what's a positive divided by a positive?
A positive.
Positive.
Now, if it had been down here, positive, negative, that would have been a negative divided by a positive, which is negative. But it wasn't. So. We haven't done degrees yet at all. So let me do one more problem with radians, and we'll look at the degrees. I'm not going to find a reference angle. I'm not going to do anything. I'm going to use common sense. So this is pi over 2. This is 2 pi over 2. Where's 3 pi over 2?
Oh, yeah.
So with the unit circle, what would that point be?
0, -1.
0 what? Up here?
0 up 1. Oh,
0 up 1. What would this point be?
right 1 0.
What would this point be?
Left 1 0.
And what would the point that we want be?
0 down 1.
All right, now. Wouldn't we just take y over x?
Yes.
So what is a number over 0?
0.
Are you sure? Zero in the numerator would be 0. What is a 0 in the denominator? Can you have a 0 in the denominator? Have you ever had a 0 in the denominator of a fraction? It's undefined. So a 0 in the numerator is cool. 0 over 7 is 0, 0 over 9 is 0, 0 over 12 is 0, but you can't have a 0 in the denominator of a fraction, right? Yes, no?
Yeah, I get what you mean.
So notice that I'm not going through any work when the angle is quadrantal. What's quadrantal mean?
It's on the line between two axes.
The terminal side lies on the one of the axes, right? Now, I don't know what the book's doing and I don't care, it's confusing. All I'm telling you to do is go to the closest horizontal. And I don't care whether you add or subtract, I don't care. You're gonna go to the closest horizontal and you're gonna get a positive acute angle in the first quadrant any way you can. All right, here we go. So this is 0 degrees and over here is 180 degrees. So what's the closest horizontal to 150?
180
So
degrees.
check this out. If I take 180 minus 150, what do you get?
30 degrees.
That's your reference angle.
I see what you mean.
So now we're going to take the sine of 30 degrees. Well, this is 30 degrees, isn't it? And are we looking for the y value? What's the y value of the 30-degree angle for the point?
1/2.
So now we already figured this out, that this angle is in the second quadrant, right? Yes?
Yes.
So what's the signs in the second quadrant? Aren't they negative, positive? So when we find the sine of the actual angle, we know the answer is 1/2, but is it positive or negative? I don't know. Look at the signs. What is it?
Positive.
Positive. And the reason why it's in quadrant 2, and we have a negative positive, but the y value is positive. Remember, cosine is x, sine is y, tangent is y over x, right? All right, I'm going to erase this and let's do another problem. Cosine of 210 degrees. Well, this is 0 degrees, and this is 180, right? What's the closest horizontal?
180.
180.
Now, watch this. Remember, before I took 180 minus something, and now I'm going to take 210 minus 180. Well, Miss Birch, how do you know what you're doing? Like I said, do whatever it takes to get a positive acute angle in the first quadrant. So in the last problem, you saw me take 180 minus, what was it?
150.
You saw me take 180 minus 150, and now I mixed them up. I don't care. Like I said, do whatever it takes to get a positive acute angle in the first quadrant by working with the horizontal. So what's 210 minus 180?
30.
So now we take the cosine of 30 degrees. Well, what's the cosine of 30 degrees?
Oh yeah. Radical 3 over 2.
So now we're going to evaluate the cosine of 210, and we already figured it out. It's down here, right? Right? And aren't the signs down here negative, negative? Well, what's the cosine? Okay, so we know the answer is radical 3 over 2, but is it positive or negative? I don't know. Look at the x value.
Negative.
So I don't know what the book's doing. The book is trying to use coterminal angles, and it's like, I don't know. This just really isn't that important. Just go to the closest horizontal and get a positive acute angle in the first quadrant for the reference angle. They're doing like 20 steps, and I don't even know if I get what they're trying to do. Okay, let's do one more. So we want to find the reference angle. So I don't know. Let's look at some horizontals here. 0 degrees is there. 180 is over here. A full revolution would be 360. Well, that's not close. So 180 more would be what? $180 more would be what?
540 degrees.
540.
And then what would be 180 more?
720 degrees.
Well, that seems like it's pretty close. So I'm just going to take 720 degrees and subtract 690. And what do you get?
30 degrees.
That's pretty good. Right? Yes, no? Is this a positive acute angle in the first quadrant?
Yes.
Okay. So now we're going to take the tangent of 30 degrees. Well, what's the ordered pair for 30 degrees?
Radical 3 over 2 and 1 over 2.
So isn't the tangent going to be y over x? Pay attention. Isn't this 1 over radical 3? Can't have a radical in the denominator. So good thing you know how to rationalize, because you're going to have to do that like a million times in pre-calculus. Can't have a radical. So remember what we did? We multiplied by itself, radical 3 over 3. Right? So what'd you get? Who gets to come out on the bottom?
A 3.
And on the top is going to be radical 3. And guess what? That's simplified. Why is it simplified? Because you can't have a radical in the bottom, you can't have a fraction under a radical, you can't have you can't have a perfect square under there. Remember the conditions? Remember I told you, can't forget those conditions? No radical in the bottom, no perfect squares under the radical, no fractions under the radical. The index has to be as small as possible. Okay, so the third step is the tangent of 690. Well, we already know where it is. We know the answer is radical 3 over 3, but what quadrant are we in? This is 720, remember, right? So where's 690? Is the 690 going to be in the first quadrant or the third quadrant?
Would it be in the
Wouldn't
fourth?
it be in the fourth quadrant?
The angle's going like this, right? So if that's 720, wouldn't it be here?
Yes.
And isn't it positive, negative here? Yes, no?
Yes.
So what's tangent then?
It'd
Well,
be negative?
cosine is positive, sine is negative, and tangent is y over x, right? So what's a negative divided by a positive?
Negative.
A negative.
Negative. A negative divided by a positive is negative. So lots of radicals, lots of rationalizing, like every day. Yeah, we're just getting into it. All right. Do you guys have any questions about anything? So just to kind of summarize, when you have a quadrantal angle, you're not going to go through all this work. You're just going to use common sense. And you're on the unit circle, so you're dealing with the points. Right 1, 0, 0, up 1, left 1, 0, and 0, down 1. When you are finding the reference angle, the radians are easy. Just look at the denominator. But what you're doing, regardless if it's radians or degrees, you're going to the closest horizontal. Because we don't want to have to graph the actual angles. I mean, you can if you want. But we're cheating. And we're going to the closest horizontals to help us out. Because we don't want to graph. We just want to know what quadrant does the terminal side lie. All right, we're going to go into our Math Wizard teams, and you guys are going to we're going to try to do this assignment that I put in. I'm calling it a quiz, and I didn't give you the answers on purpose. So I'm going to give you the answers. I'm going to say the answers out loud. I don't want you to look at the answers. So I want you to be able to do this and see if you can do it without looking at the answers. All right. Now, if your problem, I did a lot of harder problems here. If your problem is a reference angle, you don't have to go through all that work. If your problem is the reference angle, it's going to be half the work. All right. Now, in your team, I do not want you looking at your notes. I want you to do this first page together in your team, but you're not looking at your notes for the first page, okay? All right, I will see you in your teams, and then I'm going to see you back here at 2:05. All right? Okay, anybody have any questions before we leave? Okay, I'll see you in your teams then. All right, hi guys. All right. So you should have been able to do the first page, and so I'm going to read off the answers for the first page. All right? All right. Number 1 is 0 degrees, 0 radians, and the point is right 1, 0. Number 2, the angle is 30 degrees, pi over 6 radians, and radical 3 over 2 and 1/2. And make sure when you write the ordered pair, you put it in parentheses. Number 3 is 45 degrees, pi over 4 radians, and radical 2 over 2 and radical 2 over 2. Number 4 is 60 degrees, pi over 3 radians, 1/2, and radical 3 over 2. And number 5 is 90 degrees, or pi over 2 radians, and the point is 0 up 1. All right, if you missed any of those, you need to do it again until you can do it perfectly. This could cause you to make lots and lots of errors, and so it's critical that you know this stuff like really good. All right. Okay, anybody have any questions about anything else? All right, what is the reference angle?
It's one of the angles in the first quadrant.
It's a positive acute angle in the first quadrant, right? Okay, what is cosine of theta? What does it represent?
Your warranty past the factory cutoff. And this is a courtesy call to renew
What does cosine of theta represent?
If you are interested in renewing your auto warranty now, please press 5 now. Or press 9 to be removed from our list.
All right, what sine of theta represent?
The y coordinate?
Right. So cosine of theta represents the x coordinate of the point, and sine of theta represents the y coordinate of the point. What is tangent of theta?
Y divided by X.
Right. So it's kind of a weird concept, and I probably will show you more about where it comes from in pre-cal. But what you need to know right now is that on the unit circle, for all of those angles, there's a point associated to it. So you know the angle is the rotation of a ray about its endpoint. But there's also a point on the unit circle that's associated to those angles. So those points actually come from geometry. So those points are coming from special right triangles that Ms. Fresco talked about. Remember special right triangles? Remember that? So that's where those ordered pairs are coming from. They're not like mystically appearing. They're coming from building right triangles. Watch. See the triangle? So that point right there is coming from the work that she did. This is X, this is Y. And it's coming from what she did with special right triangles. That's where the ordered pair is coming from. And so for all of these points, you can build right triangles. 30, 60, 90, 60, 30, 90, 45, 45, 90. All right, any questions about anything right now? All right, you guys, I'll see you on Monday then. Okay, I'll see you on Monday. Have a great weekend. I'll see you on Monday. All right, bye guys. Have a good one.
Bye, Miss Bridge. Have a good weekend.
Bye, Daniela. Thank you, hon.